oh gosh. There we go. All right, so voices off. Thank you. We'll talk after. Voices off. Working on these 4 problems. So silently means completely independently, not whispering, not silently gesturing to your neighbors, completely independently. Try these 4, and we'll pick up with it in 1 second. If you have your participation tracker or any old problem sets to turn in that you didn't have yesterday, I can grab those. I'm passing back any that I did get yesterday. Everyone else's voices should be on. Then we'll be good to go. We got what? 1 gone? That's cute over there. That's not 1. Okay, I'll be there 1. Who else? Is he here earlier?
Yeah.
Okay, thank you. Okay. Sorry. I know what I know. Okay. Last ones. If you haven't given me your participation tracker yet, then if you can, if you can just put that in my inbox on your way out, that'd be great, because I'm going to now stand up here and start. All right. Here we go. Today's Friday, so it's Raffle Friday. Woohoo! I'm going to talk in a second. Yeah, Leo, we're excited. But for your enthusiasm? Yeah. You need the I'm easily convinced. And you got a new t-shirt. Okay. Don't worry, they're coming. But there's a lot of y'all, and it's hard for me to get there. Okay. I'll explain in a second how Raffle's going to work if you haven't heard. I'm sure everyone's been talking about it in the hall, because it's really but no? Okay. So we're going to talk about that. We're also going to talk about our calendar for Unit 2, because today we're starting Unit 2. But today's lesson is actually more of kind of review of some old properties of exponents and roots. So let's start off with these quick rules to recap and make sure we got them down. So lots of hands for lots of tickets. First one, how would we simplify this? Key?
X to the power of 7.
X to the power of 7. Still not sure why you're here, but I'm just going to let this go. So we got 5 over here, 2 over here. We add the exponents, so it'd be X to 7. Key, call on someone else.
Key. Adrian.
Adrian. Next one, X to the 5 to the 2nd. X to the 10th is correct, so we would multiply those, okay, and get X to the 10th. I don't know why I'm writing them down when I can just use my clicker and walk and do it. Oh, he can't call because he's gone, so I get to pick again. Third one, this one right here. Jimmy? X to the 3rd, so we can subtract. Think about it. If anyone's like not sure why you did that, I think it's important to see. We have 5 on the top, 2 on the bottom. It's like these 2 cancel, and there's 3 left on top. That's why we do that, okay? So last one, Jimmy, call on one more person. What will we get for that last one?
to the power of -3.
To his old table, loyalty table. X to the power, one more time?
-3.
-3, because you do 2 minus 5. Another way to write that or think about this, I want you to add that on. Anyone think of what's another way for us to write a negative exponent?
Oh.
Jeannie?
1 over x to the power of 3.
1 over x to the power of 3. So picture if these 3 would have been on the bottom, that's 5 on the bottom, 2 on top. They cancel. These are the same thing. So when you have a negative exponent, that's the same thing as having that on the bottom. Yep.
What if we knew x -3 was like they were counting wrong?
No. So thank you for clarifying. I am saying that these two could both be your answer because those are equivalent. Okay? Cool? So these could both be your answer, those are equivalent. But I don't want you to just think, oh, okay, I'll ignore that because later throughout the year, we'll be needing to know that the negative exponent and this are the same. And so, like, both of them have both of them, like, in your head as a homework. Cool?
Yeah.
Love the tickets. Okay, cool. So, for this unit, let's take a look at your calendar. Today is the 22nd. We're just going to be doing roots and exponents. Next week, we got a big week. Lesson. 5 lessons. A lot that we're covering with this unit. But then the next week, yay! We only have 3 lessons because Wednesday we'll have a short quiz. And then, I don't know if you know, but that's 6. You have the day off. I have like teacher school, but you have the day off. And then you have the next Monday off too, 4-day weekend. Yeah. What are you doing in California? Which part? I drove there. Did you fly? Are you flying? Are you flying? Yeah, we drove. It was long. Alright, but anyways, bring it back. Okay. And then that brings us to eventually this last week by mid-October. Mid to end of October, we'll be kind of having a week similar to this one where we've got like a quiz, review, unit exam, okay? So you have this calendar to reference. I will, of course, be giving you lots of updates as assessments get closer. And on the front, you'll see the standards that I'll be assessing. But again, I'll go over those when we get closer to like actually having a quiz or something. Yep.
Just like, what is with these?
Yeah, so I just passed back. If you had a like problem set that you hadn't turned into me before, I graded and gave those back, and then I also graded participation trackers last night. So if you gave that to me, I returned it. If you gave it to me today, no worries, I'll put it in over the weekend. You'll notice on that participation tracker, I mentioned because of Harvey, I was going to curve to account for the fact that we missed like 2 weeks of stamps. So the blue number up at the top of your paper is what you actually end up with in the grade book for your participation. Okay, and so if you have access and can get online, you can see that. But if not, you have it there. So, or are you saying like what should we keep as we go to Unit 2?
No, like where do you put it in our folder, like this?
Yeah, so I would keep all of your, again, I do not have a way for all of us, like a binder that's like, in tab 1, you keep all your notes, in tab 2, you keep all your this. But I would for sure keep track of anything with a grade on it, assessment-wise, especially until you get your grade from me so you can make sure nothing fishy goes on, okay? So hold on to those things somewhere safe in like your pre-cal binder or a folder, okay? All right, moving on. For the raffle today, you will be accumulating tickets, and you might be wondering what are the prices today. So to mix things up, at the end of class, we'll finish just a few minutes early, and there will be 2 winners. I'll pick 2 tickets, okay? Those 2 people will win one of 6 possible prizes, and to determine which one they get, they will be rolling this fake dice that someone had made for me because I didn't have one this morning. So they'll roll it, and they'll be like, woo! So I rolled a 1, okay? So these are going to be your prizes. If you roll a 1, next week I'll cross some problems off your problem set. You get less. Okay, if you roll a 2, You get to request whatever your favorite is. Maybe you like Takis, maybe you like M&Ms. I'll bring it to you on Mondays, okay? 3. Ooh, we're all winners. If you roll a 3, then all of us get cookies on Monday.
Nah.
Oh, nice cookies in your hand.
I
Got it.
okay, but I don't want to give it to them.
Oh, you don't want to share.
Oh.
Well, what if someone else rolls it? Now you're
That's
not.
different. They got shared.
Then 4, if you roll a 4, I can't remember. Oh, a gold medal. Here it is. Real gold. Okay. If you roll a 5, you actually do not get anything. You have to do something for all of us. You have to show us your best dance. We got to see Lirio earlier today. Beautiful. I was telling, were you in Jason's class last year? Jason Benitez? No. Last year, Jason Benitez, I did this at like the end of the year, and he worked at Chuck E. Cheese, and he did the Chuck E. Cheese dance for us. It was phenomenal. Alright, and then last but not least, if you roll a 6, you get a thing of bubbles.
Ooh.
And you can play on the beach, it'll be a lot of fun. Roll to help. So, lots of participation today because everybody wants bubbles to roll. Okay. Voices up, let me explain what we're going to be doing first. Okay. So that I can kind of limit my talking instead of just like telling you all the rules for exponents and having us write them down in our notes, I'm going to kind of mix things up. And similar to the do first, where we recapped what happens when you multiply, you would like add the exponents. There are going to be some other rules that I have kind of like dumped into 3 buckets, okay? So on this pink paper is going to be kind of dealing with one thing, the green something else, the orange something else. In a second, I'm going to pass out these papers at the tables in an entire group, so like say Marissa's table, you guys will get all one color and you'll go through it together, okay? When we come back together, your group is going to have to just like summarize what you learned and observed on this paper with everyone else. So if the do first was your paper, you would come back and you'd be like, we noticed that when you multiply 2 things with the same base, you add the exponents. When you're raising a power to a power, you multiply or something like that, okay? And that way you're going to kind of share with everyone instead of me talking. We'll record it in our notes and we'll practice with it, okay? So pink is one group, green, orange. So there will be multiple tables with one color, but everyone should be prepared to share something out when we come back. And then you will not have had the other papers, so you'll need to listen carefully to like what the other groups were looking at because you didn't examine that, okay? So I'm going to pass out to the groups right now. As soon as you get it, go ahead and jump straight in to following the directions on the paper and seeing what you noticed and being ready to share with everybody else. All right. Orange for y'all. Green. This should only take about like 3 minutes. What are you doing, Key? You opposite right now? Yeah, you can write on this paper. It's just so that I can see easier what you're doing.
Yeah, it's all girly.
Sorry. Make it orange. Alright, take a look. You've got like just 2-3 minutes, so quickly get started. See what you notice. Yep. Okay, so for example, if 5 squared is 25, we know that, right? Then the square root is like the opposite. This is the square root. Okay, ready? If 2 cubed is 8, then the cube root of 8 is 2 cubed. Okay. So they're like opposites. So let's generalize. This is the rule that like they say in textbooks. If b to the power of n equals a, then we could always say, see if you can figure out like what it is. Okay. When you plugged in your calculator, 25 to the 1/2 power
When did you notice?
This is a power, not one.
Square root.
You have 2, 1 equals,
Gary,
sorry, 1 half.
you can't be silent.
You get 5. If you do 25,
I get it. Oh no, it's almost 3.
So what do you notice? What do you call that thing? So 1 half exponent is the same as a square root. Because it technically has like a little so you can write that you notice that. So then here in general, x is 1 half is something as root x. When you think about when you have a third, like that. It's now okay, what do we got? Okay, so how would you, good, this is like kind of your explanation. If someone didn't have a calculator and you had to explain it as why, how do you like explain it?
Well, it's a general question anyway.
So that's gonna be the goal. You're gonna have to like not just be like, and it equals -6. You're gonna have, they're like, I don't get it. Why is it equal -6? You kind of had it because -6 to the what? Third power equals -16. So you're basically asking yourself, what to the third power gives us like what they need, right? That's what you're asking. And they don't have a calculator, but I have this chart up here. I don't know if y'all saw it. So that's the cube. Okay, a few more seconds. We're gonna be ready to share out. Alright. Bring it back. 3, 2, 1. If everyone could turn off side conversations. Thank you. Perfect. Okay. So how we're going to do is we're just going to walk through the notes like normal. But before we get to a section that I would like explain, I'm going to go to the group that kind of had that thing, and they're going to kind of explain it before we jump in. So the first thing we're going to look at our notes kind of has to do with group orange, which has something that looks like this. If you do not have an orange sheet of paper, which is a lot of y'all, you don't have this to look at. So you're using like your listening skills right now, plus I'm going to be writing a few things on the board to follow along and see what they looked at because it was different from what you looked at. Okay, so this isn't in your notes. This is just like listen, see what they saw, and talk about it, okay? So orange, I need to see some hands. Raise your hand if you can kind of summarize for me. You don't have to read the whole thing, but what did this like deal with? What did you learn? Yep.
It was just dealing with the square roots and the
Exponents.
exponents of it.
Okay, so if we have a square root and we have an exponent, like the relationship between this, okay, so can you elaborate a little, like give them an example of something on here?
Let's do the last one.
Okay, so let's talk about the last one.
Yes.
I'm going to draw it a little bit bigger so you guys that didn't have this paper can see it. Cube root of -216. They're going to talk us through how we could do this like by hand, as in not just plugging it into our calculator, but thinking about it. What would you do?
So I just said that if you just basically divide 260 by 3,
Okay.
you will get the answer.
Okay, 216 divided by 3.
No.
3 goes into 21.
That is incorrect. That is
No?
incorrect. That is incorrect.
I like that. Okay, they're revolting, I'm sorry. So I'm going to stop. You're kind of onto something, but we're not quite dividing by 3, so call in one of these guys that are like saying something else and see what they have to say. Okay, Maggie, over to you.
Okay, so basically it's saying that Bn is equal to A, and so then n is always going to be that little exponent looking thing. Okay, and so basically you're going to plug it into the equation. Like I put Bn is equal to A, and then I put B and then 3. And where this says n over there, on that side? No, on that side.
Uh-huh.
I put 3. Yeah. And then for A,
For this problem, you're saying.
yeah. And then for A, I put negative 216.
Cool.
And then basically you just ask yourself what times to the power of 3 gives you.
Cool. So if we've got a cube root, she's translating this to saying, I'm asking myself, what, I'm going to repeat what she said, what to the power of 3 will give me negative 216. That's what we're looking for, okay? So we're looking for that mystery number. I don't expect you to necessarily know like all your cubes. Like we know a lot of our squares, right? Like 4, 9, 16, 25. I don't expect you to know all of your cubes. So to help us out today, I have all of our squares, cubes, things to the 4th power. So if y'all take a look, where do we see 216 in our cubes over there? What to the power of 3? 6 to the power of 3 is 216. So we have negative 216. It would be negative 6 times negative 6 times negative 6 would give us negative 216. Okay? So what to the power of 3 gives us negative 216 is a good way to think about a problem like that. All right. In your notes, this is the part where it says nth roots right here. So if you could look there, thank you, orange groups, for sharing with us. I'm going to come bring you some tickets while y'all record some things. Everyone else. Okay. Right here it says, kind of like what Maggie was getting at, a to the bn. Then we can say that b is the nth root of a. If a is equal to b to the n, then we can translate that. I give you half and I get half so the numbers match. So if I pick it. Huh? I should have won. You got multiple. Okay, I'll come up. Are they, and they match? They match? They're the same number? Yeah, you just got 2. What happened is I forgot that I already gave you one. I brought you one. So you just got lucky. Alright. If we have the 4th root of 81 equals 3, right? That means that 3 to the what power? 4th power equals 81, right? We can go back and forth between these two. Or for this one, negative 5 to the what? 3rd power is negative 125. So you've seen this before. We can go back and forth, but we're just getting familiar with this again. Okay. In this chart, I'm not going to go through everything, but one thing I want to point out is when n, the root thing, is even and when it's odd, okay? Remember in Unit 1 we talked about how with our domain restrictions we couldn't take the square root of a negative?
Yep.
We were like, no, like when we threw out those numbers. Okay, so why, my question for you for a raffle ticket is, why right here do I have the cube root of negative 125 and that's okay? Like why is that not, no bad? Why is that okay? Eric? I mean, sorry. I know you're not Eric.
Aaron.
The brother Isaac. Have I done that yet? No. See, I know you are. I just tired. Okay. Isaac. Everyone else, bring back. Isaac, sir. Why can we take the cube root of a negative?
The negative number is multiplied 3 times. So if a negative number is multiplied an odd number of times, then it's always going to equal a negative number.
Okay. So he says because this is a cube root, we're talking about a number multiplied 3 times. Negative times a negative times a negative could be a negative 125, right? Yes. When we had the square root, can a negative times a negative ever be a negative? No, so like we said that is not going to give us a real answer, and so we said like it was not possible. You'll get imaginary numbers for that, okay? So to clarify, when we were talking about roots of negatives, we were talking about square roots or 4th roots or 6th roots. Anything that was even is going to have 0 real roots when we have a negative number underneath, yeah? If it's odd, you're good, okay? So I just want to clarify that when you're seeing these negatives. Okay, let's move on to group 2, our pink group. Looked at some other examples. So orange people and green people, you do not have this sheet of paper. So you're just listening and thinking about these. This is your needed. 25 to the 1/2 and all these examples. Raise your hand if anyone from the pink group can share what they noticed. Jason, go for it.
Alright, so it took me a very long time to notice this. But what my table was talking about, something about like the square root. So basically what I did was that I divided, well, I got half of what the number is. So for example, 25.
Oh, I see. Hold
So
on.
getting half of it is 12.5.
Okay.
Okay, so then what I did was that.
Here you go.
Oh wait.
I'll let you finish, then I'll go with
Look what I did.
You multiplied times 1/2, right? And you
Yeah,
got
I did.
12.5.
Yeah.
But your group was saying it was something with the square root. So
Oh, well, then I did it myself.
you're good. I agree with you. 25 times 1/2 is 12.5, but in this case, we're taking 25 to, it's like a small little exponent, to the 1/2 power, which is what you said at the beginning. You shared like what your group was coming up with. So someone from your group, when you did 25 to the 1/2 power, what did Jesus you get? 5.
Wow.
And for this, they got 3, 6, and 10. So I'm going to go over to Karen. What did you notice, which you might have heard Jason kind of say briefly at the beginning, but what did you notice that taking a power of 1/2 is the same as?
We said that when it's raised to the power 1/2 is the same as the square root.
It was the same thing as a square root. Okay, so in general, something to the 1/2 is the same as square root of x. So someone else from the pink team, if I have it, let's say I'll write it bigger for everyone else out in the crowd. If I have it to the 1/3 power, Jose, what's that the same as? The cube root of x. The cube root of x. So whatever's on your root, whatever type of root, the square root, the cube root, the fourth root, that's your denominator of your fraction. Okay, there's one more thing I'll point out. I'm going to draw this a little bigger. What about if we don't have 1/2, but we have 3 halves? What did this group notice when they have 3 halves? Yep, Samantha?
We noticed was that when you have 3 halves, that when you know how you get the square root, you only have the 2 at the bottom, so then if you have the 3 on top, you have to find you have to choose the square root and
Cool. So everyone that wasn't on this team, we noticed that the half, since it's still a half, it's just 3 halves. The half is still a square root, but since there's a 3 on the top, that means it's raised to the 3rd power. Actually, it could also be like this, but either way, the 3rd is still an exponent, and the half is still a root, but the order doesn't matter, okay? So in your notes, to kind of summarize, this box at the bottom of page 1 is saying the same thing that our pink group, and Samantha, I'm coming with your ticket, that this pink group just came up with, okay? Taking a look, if b is raised to the power 1/n, then that's the same thing as the nth root of b. You just take that root, okay? If I have b to the power of m/n, then m is the exponent and n is still the root, okay? So let's look at an example with numbers and do some practice here before we go on to group 3, okay? Flip to the top of the next page. Flip to the top of the next page. If I have 49 to the 3 halves, I could either write that as the square root of 49 cubed, right?
Yeah.
Or I could write that as 49 cubed with the square root around it. We can go back and forth between these. Raise your hand if you can tell me which of these you would rather do by hand right now, because we get to choose. Both of them are equivalent if you put them in your calculator. Which one would you rather solve, Adrian? First one, right? The square root of 49, you know. 49 cubed, you're going to get this huge number, and then take the square root. Calculator might be okay, but if this is non-calc, we would want to do this. So it's important with these properties to be able to go back and forth and know which one you want, okay? So come in with your ticket. Root 49 is equal to 7 and 7 cubed. If you don't know it, that's okay. Come over to your paper. Shimmy, what'd you get? 343. All right, I'm going to set my clock for just 2 quick minutes. I want you to do as many of these as you can, just practicing that. Then we'll check them and we're moving on to new properties with group green. 2 minutes. You and Adrian. Keep going though, keep going though. So 1/2, like the half on the bottom, and 2 on the bottom is the, because this is technically a square root, it's talking about the opposite of something squared, right? These are opposites. And so if I have 1/2, that's the square root, okay? If I have 1/3,
What if I have a 4?
So you're not just going to say square root of 16, that would be 4. We're thinking about the fourth root, so let's get these fourth powers. Do you see 16? There it is. So 2 to the fourth power equals 16. So you're going to check 2. Time check. You got 45 seconds left. Do as many as you can. If you're not sure how this is working, call me over to get some help before we come back together. How to solve that? This is correct. You're setting it up correctly, but now solving. The fourth root is 16. If you take it right here, there's 16 to the power 4. So what to the power 4 equals 16? 2 to the power 4. So this would be equal to 2.
Meanwhile,
Because 2 to the power 4 is 16, right? 2 Okay, so this root 25 is 5. And then yep, perfect. Alright. Okay, we're gonna quickly check these to keep us cruising. So I'm literally just gonna write up the answers. I want you to just check off and we're gonna move on. If you are like, what? I got different numbers, I can take one quick question, but beyond that I'm gonna ask you to then check in with me when we get to practice later again. So I have this 343, 2, 125, 27, 16, 64, 16, and 36. I'll take one question and we move on. Jose?
Where you got the answer number 2.
The second one? Did you get 4? Yeah, a lot of people today have been wanting to say that this is 4 because they automatically took the square root. But if this has a 4 on the bottom, it's actually a fourth root, which means you're asking yourself what to the fourth power equals 16? And that would be 2 times 2 times 2 times 2 would be 16. So 2 to the fourth is 16. Cool? Good question. Alright, moving on. Last group. Group 3, green group. Here we go. Everyone that didn't have a green paper, take a look, listen carefully to see what the green group noticed. Volunteers from the green group to share what you saw on your paper. Man, a quiet green group. Jimmy, thank you. Go for it.
So, you know that we put all this in the calculator.
Okay.
The square root of 50 was like 7.071. But the 4 to 25 times 42 is also 7.017. And then the same thing with the 1 to 2.
Those were also equal. You don't have to get any numbers, but they're equal. So what did you conclude, or like what is there to learn here?
That you can like take like you can like factor kind of, and then
Perfect.
you can put it together and like the
Okay. So 50, do you agree 25 times 2? Those are factors of 50. 25 times 2 is 50.
Yeah.
If I take the square root separately, I still get the same answer. Okay? So that's helpful. You might remember this from algebra. The reason we do this is because if we don't have a calculator, let's say we couldn't find those decimals. This one, I'm kind of at a stopping point, like if I don't know the decimal, because I don't know the square root of 50. However, if I break it down, can I take the square root of one of these things? Root 25 is what? So you might have rewritten root 50 as 5 root 2. We call this like simplifying radicals. And you can at least take the square root of like part of it, even though you can't take the square root of the whole thing, okay? The 5 is not the little number because it's not now the 5th root. 5 is a number, like the value of root 25 is 5 times, this is multiplication, so I made it big, times root 2. Cool. Okay. So root AB is the same as root A times root B. You can basically break it up. What do we find green group with division? Really quick summary before we go back to our notes. Can we split it up with division as well?
Oh, yes.
Yeah. So they could also like break it apart with division and say this is the same as root 9 over root 25. Okay? In your notes, that's this part that says radical properties. So take a look at your radical properties. Same thing as what Jimmy was talking about. We can split apart or put together factors and take the square root of the separate parts. Or not square root, like any root, nth root. Okay? Same thing with division. I can either pull it apart to two separate ones or I can put it together into one. Okay? And you'll have different times that you want to do different things. Okay. So when we take all of these things, okay, we take them all, we end up with a bunch of strategies and tricks and tools to simplify expressions. So we're going to pick up with this cube root of 16 p to the 10th, q to the 7th, like all this crazy stuff. We're going to pick up there, and we're going to talk about how we can use all of these properties to basically do the cube root of like as much as possible that we have here, okay? So if I have the cube root, man, it's like a busy day. Do it all feel like it's like traffic here? Man. Leo. Oh, ignore everything? What do you need from Leo? Oh, to the front office. Now we all know. Okay, cool. If I have the cube root of 16, p to the 10th, q to the 7th, okay, you're like, what? I'm going to write this a little bigger so that we can see it. I feel like the PowerPoint is small today. Using the product property, can take the cube root of like these as separate pieces, right? So I need to take the cube root of each one. I don't necessarily need to write it as like cube root, but like we need to know that we can take the separate pieces, take the cube root, okay? So I go to take the cube root of 16. Oh no, I don't have 16 in my list of like perfect cubes, bummer. But let's think back to that last group Jimmy just shared. We broke 50, do y'all remember we broke 50 into 25 and 2? Is there something I can break 16 into where there's a factor that is a cube, Josh? 8. 8 times what? 16 is equal to 8 times 2. Yeah, you're good. So we can't just leave 8, but we can say 16 is 8 times 2, right? And take the cube root of this part, and then we have to leave behind the 2. We can't take the cube root of 2, but we got better, right? We're closer. Okay. I'm going to leave that for now. I'm going to keep breaking down these so that we don't have too many steps, okay? For p to the 10th, again, we've learned a lot of ways today we could rewrite that. Like, I could rewrite it if I wanted. It's not going to help me in this case, but I could rewrite it like this, right? That's p to the 10th. I could rewrite it like this. That's p to the 10th, right? So there's lots of different ways we can rewrite that. We would like to have something cubed, because a cube and a cube root I can cancel, like it'll undo it, okay? So I could rewrite this. Again, there's multiple ways you could do this. But I could say I have 3, 6, 9, 10 of them. Do you agree this is the same thing as p to the 10th? Okay, if I break it down. And all of these have a power of 3 that I can take the cube root, and then this 1p, now I get to see what like is left that I can't take the cube root of. Hold on, I'm going to do this one. Okay, for q, I could do something similar. Help me out. Q cubed. How many more do I need? How How many do I have now?
6.
So I need one more to have 7. This is literally, and like you'll get better at this and you won't necessarily have to write all this down, but this is equivalent to this, but now I'm showing things that can be taken the cube root of, right? I'll highlight which parts. I can take the cube root of 8, right? Can I take the cube root of 2? I'm going to leave that. I can take the cube root of all of those, right? What about P? No. I can take the cube root of all of those, but then I got to leave behind Q as well, okay? So let's go ahead and actually find the cube root of these things. The cube root of 8 is 2. The cube root of P cubed, P, do you agree? All of those would give us that, okay? What about this one? Like, I don't know why it's so funny, but okay, anyways. And then that leaves the cube root of what's left inside? The 2, the P, and the Q. So I'm going kind of like step by step. I'm showing you like all of the things to try to like show where this comes from. Okay, the last thing I want to do is like, I don't really want to write P times P times P. I'm just showing you that that's what we got. So P times P times P is P cubed. Q times Q is Q squared. And then I've got the cube root of 2PQ. So all of the things that came out front came from these red sections when I actually took the cube root of those things. So they are now in front of the cube root, like the cube root is gone. These things inside, I only had one of them, so I couldn't take the cube root, so the cube root is still there. Okay? Okay. The only other thing that happens when you're doing these that you have to be careful of is if we look at this special case right here, right below. Take a look. I'll be right back. If I have the 6th root of n to the 18, here's another trick. How did they rewrite that 18? As 3, because we said earlier you multiply those, right? So they rewrote n to the 18th as n cubed to the 6th power, because now they have the 6's, and the 6th root of 6 will cancel, and I just end up with that n cubed. What do you notice is around the n cubed though? Absolute value. So this special case says that when we take the even root like this, we want to make sure that that n cubed is not negative, because we had an even root, and we talked about how we can't take even roots of negative, right? And so when we take the even root of something like this, our answer needs to have an absolute value around it. So this one was a cube root, so we didn't have to worry about that. We could have negatives, we could have positives. This one we only wanted to have positives underneath there. Okay? Okay. With that being said, I want y'all to try. I'm going to have you try one just because this is like the new stuff that we finally got to. I want y'all to try these two before we get out of here. If you have time for more, you can keep going. I'll be around to help out and give out tickets to people I see trying stuff and asking good questions. And then I will draw in just a little bit. It's not in our list. You can, it's just a decimal. But we could break this down, right? You see the list of squares that would have like a factor 62, 63 is 1 times 9 times 7 is 63. So I want you to rewrite it as the square root of 9 times 7. Because we can take the square root of this part, right? And then y squared, y cubed, if we wanted to have everything like that. This is still y cubed, right? And then now, pull those out front. And these ones are gonna be like 5, right? So we broke down 63 into 9 times 7, so we can take the square root of 7. This y, is that your square root for the root? Yes, sir. It's like real questions, calculus. Why use the trick? Have y'all learned that yet? You have? Okay. Just this for right now. So this is 1/2 t. Did you? This is just rewriting it. Okay. So 1/2 t. Is that your t or your plus sign? Okay. So you want 1/2 goes in front, right? T to the power, you subtract 1. Right? You always subtract 1 from the power. Negative 1/2. Cool? Plus negative 1, right? You're going to get out front t to the negative 2. Yeah, and you'll be ticket for you. Yes, ma'am. Yes. Okay. All I did was from here to here. Okay. All I did was I just don't want to write this. So I just go from here to here. Which one? Okay. So when we look at this, the things I underline, because they actually have a third power or I did.
You better not.
T, I can, Q and U I can, and then alright, y'all. For this one, just to kind of recap and have you check if you got to this one so that I can draw. For this one, I broke it down this way if you took a look, and I can take the square root of these two things. So I got 3y times the square root of 7y. Only thing to be careful about is, what did I just say for a special case? If this is an even power, a square root is an even power, I say the absolute value of y to make sure that this y was not negative. So 3 absolute value of y is the square root of 7y.
What can we do 3y?
This y came from in here. We cannot take the square root of a negative, so we want to make sure that this is not a negative number and the absolute value is not positive. Okay? Cool. All right. Great questions. I know we didn't practice a ton when we got to these things, so Mondays due first will be more of these for us to practice some more. Okay? Here we go. Drawing time. 2 lucky winners. Last 3 digits. First winner is 464. Come on. Oh, they might have left, so I might have to keep drawing.
Okay,
461.
Wait.
Come on down, Maritza. Come on down. And then 472. Okay, you two. You're gonna be okay. You can still get cookies if they roll right now. Okay. Maritza, roll for me. Maritza got a 4. Hold on.
That's a gold medal.